Hello, how are you to everyone? And today I am repairing the HOMAGE Neon 1003 and the fault is 03. I'm just turning on the inverter. As you can see and as you can hearing the fault, okay, and the pen is too damaged, okay. Let's check. And our tomorrow project is very beautiful. This is our tomorrow project Growart SPF 5000 TL HVM 48, and we have in this fault 03 and fault 08. Fault 03 is related with the battery voltages as too high, and fault 08 is the bus voltages is too high, and this is our tomorrow project, okay. Now we need to repair this in this live stream because the title I write or type for this. Okay, first we need to disassemble this. Here we have one screw, and here we have one another. And thank you for my all US viewers. Okay, and here we have a hooks, okay, the one is here, and after that okay, here we have a one big hook, okay. First we need to remove this LED panel strip, and this is the LCD, and this is the switch panel strip. After that I need to clean this, okay. But first I need to remove, first I need to clean this, and I am not unmuting my mic, so you need to down your phone volume because in one live I forget to again unmute, so now I am not muting my mic, okay. You need to down your phone volume. Okay, I clean this. Now I don't write this, okay. This is the person who writing this codes to repair again because they don't know about, just they remember from here. So the person always writing again and again, again and again, because they want a permanent patient. But we need to repair everything perfectly. So first I need to remove this cording. Okay, and now people not giving to this person because it also works like this, and this is not the good thing to write an inverter. Okay, this is the air ventilation plastic core. Okay, you can call this core an air ventilation. This is for air ventilation. Okay, for this specific area. And after that I need to remove this and this. Okay, and this is the solder, so I need to remove this solder. This is the line, input line, and this is the input neutral. Okay, and after that I need to remove this strip, and this is the pen strip, and the pen is too damaged. Okay, so we need to replace the pen. Okay, I'm just removing the main board from the body. After that I need to remove this. This is for the output, and here we have a hook. So first you need to push this hook, and you can easily remove the main board from the body. Okay, now we need to troubleshoot quickly this issue because this is not a very big issue. I think our DC to DC boost section MOSFET is okay, but we need to check this. And how you can check this properly with control drive circuit. Okay, I am teaching you. This is the pin number 1. First I need to guide you. Pin 1, pin 2, pin 3. You can call this pin get, this pin number 2 drain, this pin number 3 source. Okay, so this is our pin number 2 drain. You need to keep your multimeter negative probe on the drain pin number 2 and just wet it. Okay, okay, this MOSFET is okay, but now we need to confirm the drive circuit. So you need to keep your multimeter positive probe on the source and keep negative probe on the gate. And here we need 600 and some ohm resistance. Okay, as you can see, this is the true resistance. Now here we need the same resistance for this. Okay, now we need to reverse the polarity of multimeter. Okay, this is the true resistance, and this is the true resistance. That's mean our DC to DC section is okay. And now we need to check the DC to AC converting section area and charging section. Okay, so how you can check this? This is pin number 1 like this. Okay, from left 1, 2, 3. Okay, so here we have a 5 N channel MOSFETs. Okay, the port is using for DC to AC. Okay, this is the pin number 2. In the middle or in the center, keep your multimeter negative probe on the pin number 2. Okay, and keep your multimeter positive probe. This is okay, this MOSFET is okay. And now here we need to check the second is okay. Now I am checking the third. Okay, this MOSFET is short, and this is the port is too short, and here we have one another. Okay, here we have two short MOSFETs. Okay, in this case, first you need to check the 220 ohm. This is the special tip if you are working on solar inverter. Okay, or any inverter. Here we have in this type of boards. Okay, in this type of boards, a 220 ohm resistor for gate drive. Okay, so this is our 220 ohm resistor. Okay, so this is okay, and here we have one another. This is okay. If you receive a true value resistance of this MOSFET, so you don't need to worry about any drive circuit. Okay, and if you receive a broken or D value resistor, so you need to check this PNP transistor and diodes. Okay, and the second icon is that if you receive a broken MOSFET in everything, not just in this board, if you receive for repairing a broken MOSFET or blasted MOSFET, so you need to check properly every component per drive. Okay, so in this case we have just a two short MOSFET. Okay, and after that we need to check the charging continuity. Okay, now I am just checking the charging continuity. First, keep your multimeter probe on the pin number 2 drain and positive on the pin number 3 source. Okay, and after that you need to keep this on pin number 1. Okay, this is the true continuity. This continuity is coming from UC3843 charging modulator. Okay, so our charging section is 2. Okay, after that you need to just remove these two MOSFETs and replace this. Okay, the one is here and the second is here, and the MOSFET name or number here is 740. Okay, this is the N channel MOSFET, 400 volts, and I think 9 amps. Remove this, but don't touch the isolation pad. Okay, don't touch the isolation pad. Okay, I need to separate this from heatsink, and okay, I am applying force from another area, but here I need to use this tool, but just I need to don't touch the thermo pad. Okay, take care. Okay, finally I separate this from the heatsink and isolation pad or thermo pad, you can call both. Okay, now I need to resolder this pin and give some solder more for as you remove. Okay, and after that you need to keep this in tweezer. Okay, don't apply force, just keep, and when you know about all the solder pins, solder is melted, after that you can remove easily. Okay, with confidence, and we need to do the same process with this. Okay, And now I need to remove the solder from here to install a new MOSFET. So here I am using a desoldering pump. Okay, and I need to purchase a desoldering station, best desoldering station for saving time. Okay, I clean this, no any print damage. Okay, now I need to install a MOSFETs. I'm just searching for MOSFETs, okay, for same MOSFETs. Okay, yeah, I found. Okay, I need to check this MOSFETs because I was removed from the system and I install for modification. Okay, so I think this is okay, but I need to check this. Okay, this is okay, that's okay. And I am teaching you how you can check the MOSFET properly with multimeter. Okay, note this. Keep your multimeter or set your multimeter on continuity mode. Okay, and this is our MOSFET pin number 1, get 2, drain, 3, source. Okay, keep the multimeter negative probe here. Okay, first you need to check this internal resistance. Okay, and if you have a short circuit here, first you need to discharge the gate and after that you can check. Okay, so our internal resistance is okay, and now we need to check this. So I am providing a positive power supply power, okay, or positive voltage on the gate. So here we need a switch MOSFET. Okay, zero resistance, as you can see. Okay, the MOSFET is okay. Now I am applying a negative voltage to discharge. Okay, as you can see, this MOSFET is okay. Now I need to check this. Okay, now I am applying the voltage on the gate, as you can hear. Okay, and as you can see, and after that I need to again discharge, and after that I need to check. It's okay. Okay, so our MOSFET is okay, and I was removed this because in one live stream I was installed at 26 amps and 400 volts. Okay, and this system is a little bit just for 500 watts, so this is enough for this. Now I need to just install. Okay, it's hard and gloves, but I am trying. Remove the extra solder from the MOSFETs. Okay, and now I am just installing the MOSFET, and after that we need to check what's about. But I am working on the left hand, and it's a little bit hard to install with the left hand. Okay, First I need to tighten this. Don't apply a force here, okay? First you need to set the screw like this, okay? And after that apply the required force, okay? Now I need to install another MOSFET, but where I keep a MOSFET, man? Oops. Ah, MOSFET, where are you, man? Oh, I forgot. Where is the MOSFET I keep? Oh man. But okay, I found here. Okay, now I need to install this another MOSFET, and after that I need to just check and close this topic. Oh man. Okay, I am trying on the right side, right hand. Okay, but just it's okay. We have a little bit solder on our MOSFET pins, and this is the reason for hard install. Okay, but here I need to provide some heat, and this is not the good thing, but I do now, so I'm just giving more solder. Okay, and I need to set the position. Okay, now I need to set the position from here. I need to more push, and I does the mistake. Okay, but that's it, all right. Okay, don't worry about this. After that we need to check the continuity with heatsink. Okay, and don't forget this thing, to check the continuity with the heatsink. Okay, so how you can check the continuity? For example, this is our multimeter. Set your multimeter on continuity mode and keep any probe on the heatsink like this, and after that you need to check the self continuity. Okay, and after that you need to check this drain. Okay, this is the drain, not connected, that's okay. Not connected with heatsink, that's okay. So now we need to just solder this. Okay, and after that I need to just clean this. Oh man, some dirty words. Okay, this is my duty to clean this. This is not my work, but I am cleaning this. Now this is my duty, okay, because now I am working on this device, not others. So I clean all my works and other person works. Okay, this is my duty. It's okay. And now I need to check. Okay, so first I need to connect the pen for feedback. This is just temporary to provide a feedback. Okay, and now I'm just providing a power supply to the inverter. Okay, and after that I need to install the inverter on LCD for better result. And here I need to install my switch, but here I have a switch, so I need to install the inverter on switch and everything. Okay, this is our switch panel, and here we have one for LED panel, and here we have one for LCD. Okay, and after that, okay, this is the true direction. I'm just turning on. Okay, I not connected the one wire. Okay, now I just need to connect, and now I need to check. As you can see, okay, inverter is now okay. So this is the method of troubleshooting, and this is not the important thing to in every inverter. Just you receive this one. Okay, every inverter doing different things to damage. Okay, so you need to view some multiple videos of one model inverter. Okay, because in every inverter not like this. Okay, this components. So now just I need to fit this or assemble this again. And how I told you our charging section is okay, now I am proving. Okay, now I need to prove. And this live stream I am providing just a main AC power to run the charging system. But as you know, if you know about this, so you can confirm from here. But for some viewers, I need proof. Okay, and why I am preparing in live stream, because this is my unique method for repairing, to assist you or teach you or guide you with better method. Okay, and I learned this with very hard methods and recorded videos. Okay, but I am working and live stream. Okay, so if I want to keep something in privacy, but I can't, because this is a live stream. So now I need to just show the LCD and the amps. Okay, now my this inverter is connected with the battery. Okay, and now first I need to attach, oh sorry, and this is very difficult thing for some users. I am teaching you, I am just attaching. Okay, and let's check what happened in this clamp meters and what the magic is here. Okay, now first you need to just, okay, 16 amps, but here we have a negative icon. So now I am teaching about this confusion. Okay, if now why they showing this negative icon? Because electron are coming from this side to this side. Okay, from here to here electron going. Okay, and when I attach like this on this, so this is for negative flowing. Okay, as you can see, this is the negative electron flowing here or going from here to here. So as you can see, no any reverse polarity. Okay, and when I attach this here, so here we have a negative icon, and when I remove the AC power, okay, now the turn to electron flow with this direction. Okay, so now I am just turning on the inverter. Okay, and as you can see, the negative icon is now off. We have no, because electron is coming here from here to here, and this is the positive electron icon. And this time if I install here, so here we have a negative icon, and if I want to attach this, but I need to know any negative icon, so the negative electron is now coming here like this. Okay, this is the direction of flowing electron. Okay, so I need, as you can see, no any negative icon or reverse polarity. Okay, this is the clamp meter using method. Okay, now I need to close this inverter. It's okay. That's okay. So this is my pen I remove, and now I need to replace this pen because people are working this type of works. Okay, they just clean, but this is not the good thing to disturb the fuels. Okay, here I am for fuel, and I am not disturbing the people, so I am just removing the strap for another good pen. Okay, I clean this. And check the quality. I am purchasing this pen expensive from like this new, because here we have a brass bush. Okay, this is the pen quality, and don't purchase this type of pens or anything. Okay, I'm teaching you about the cooling pans. Okay, here we have a bush. Okay, a brass bush, but this is not the good thing. Okay, and here we have, I am purchasing this Just look at the quality. Okay, here we have you need to install a pen, and the required thing is ball bearings. We have in this type of pen a ball bearings, as you can see. Okay, now I need to protect this again. I want just to tell you about the quality pens, and this used pen is expensive from the new. Okay, I am using this type of pens from last 4 years, and no any pen I receive again. Okay, now I need to cut some piece of this. You can find this pen. This is the same feedback. Okay, and old compact CPUs. Okay, I protect this again, and now I need to install this strap with this. Okay, so how you can install properly like this? Just remove the hook. Okay, and now you need to mark the wires. Okay, to don't forget. So here we have a red on this. Okay, and black we have in the middle, and for white you can also write for white icon, just circle. Okay, in the middle we have a white color, so this is our white color identification. Okay, now I need to just remove the wires. Okay, it's soldering iron. Now just check. Okay, oh man, don't worry. Okay, I need to a little bit zoom, and okay, now I need to, and one thing I am sharing with you how you can solder easily a wires. Okay, keep this and this fingers. Okay, okay, and keep your solder and these fingers. Okay, and now just, okay, I need to zoom out. Okay, keep the wires and these two fingers. Okay, and sit with this hand. Okay, and now you can provide a solder like this, like this, like this. Okay, it's easy to solder. And after that I need to solder this again. Okay, and now here was our white for feedback, and here we have a yellow, so we need to solder here a yellow, and the middle we have a black, so I need to install here or connect here a black. and after that here we have a red, so I need to solder here a red. That's okay. And now just sit in this lock. Okay, and now need to install this label. This is not the necessary, but I was removed just to, okay, no need for model. Okay, and don't install the airflow in the inverter side, okay, because this inverter is designed for air ventilation. You need to install the fan like this, okay. That's it. Okay, now I need to just install a board. It's okay. And I receive a 2 screws for this board, okay. And I am just searching. This is my screws, okay. This is my mixed screws, and if I don't find, oh man, so I am not responsible for this because I not received in this inverter, because here it's very hard to find anything for this inverter because this is not the market of these things, okay. Now I need to install this and screws first, okay. But I found for this, so I need to install. That's okay. Mix quality code. Okay, I have a dot. Why I was silent? Because because I forget to connect my big power bank with my backup system. Okay. And when I was lost a power, so I was stopped the working because I was thinking I lost the internet, but I forget it in this time. I have a network data in my mobile network. So now I am continuing my work. I was just worried about this. I lost everything. Okay. So this was the reason. Okay. But I don't lose anything. Okay, this is the reality. So, I was installing this and now I am just installing again. Okay, so this is our third screw. But if you have a true personality, so you don't know about anything to keep in the privacy because you are a true person. Okay, so when I lost the power. After that I was stopped the work. Why? Because I was needed to connect again with the internet, but I forget it. I have a data and my mobile or SIM network. So this is the reason. Okay, I found one more screw for this. Thank you for everyone and every good comments. Okay, don't, if you cannot give a respect, so please don't do a negative comments. I was received some bad comments, but I don't care. I'm just telling you. Okay, so we need to install here a positive. It's okay, and here we have a negative. So, and look this, we have a corner, and here we have an angle. Okay, so here we have okay, that's okay. And now this is the pen strip to install, but first we need to install this because this thing is melt and the person disconnected. So on this time I have no this strip. Okay, so I need to install like this. Oh man, this length is not good for here, but after this I need to order this jack and this strip for next time. In our country I not found these types. I am purchasing from other countries. Okay, this work is not hard for me, but this thing is hard for me. The components are not available in full variety in our country. Okay, so now I need to check the fan. Okay, and I need to wait for approximately 10 minutes. Okay, and 10 seconds. The CPU warn you approximately in 5 seconds, but for good service I need to wait for 10 seconds. And one thing I am more showing you, make this type of switch if you are working on this inverter. Okay, this is very easy thing. Okay, just install and turn on. And now as you can hearing the sound and airflow. Okay, this is the airflow of this fan. Check. Okay, wait brothers, I have a call to receive. Who is calling? Assalamu alaikum. خير أستاذ خير. Stage. Patahnya gitu. Coba tadi suara si bosku. Nah, katanya lagi Ustaz. جاوید سر تا سورا بیتو که اسرا ماشین ده گای بنلشون. Okay, sorry for it, but I have a business, so I need to receive a call and give answers to people for the devices. Okay, so this is okay. Now I need to turn off. That's okay. Remove my switch. It's okay. Now I need to. One thing, remember, you need to keep everything in one box, okay? Because this screw is reminding me install the air ventilation core. Okay. Airwix 01 quality content. Thank you, man. You are a good person because you do a good comment. Okay, and thank you. Now I have just 4 screws of main core, top core. Okay. And if anyone have a issue in inverter, and if you don't know about, so you can ask from me and I can teach you in this live stream. Wait. Okay, sorry brothers, but this is the work requirement. A person called me because I am responsible. A person was called me and he told me, give your cell phone to your brother not receiving the call. So what we can for this issue? If he don't receiving the call, so you need to wait for it. But he calling me again and again, your brother are not receiving the call, and blah, here something. It's okay. First I need to check this. And here I have 100-watt halogen. Yeah. Okay. This is the charging mode. That's okay. Again, polarity. Check this. Okay, now 13.6. Depending on battery voltages. It's okay. Okay, and after that you need to discharge a capacitor with switch or with this method. Okay, but you need to discharge. Okay, and this is the condition of this man. What people doing with this inverter? What, man? This is the electricity things, and people are kidding with this thing also. It's okay. um, I need to set this, and I need to charge for this work extra. Also don't like tight this all with the palm. Okay, just tight a little screw with these three fingers. Okay, this pores is enough for this. That's okay. Okay, and now I need to set this. People are also kidding with this thing. Okay, and how you can, it's okay, that's okay. Now this is, I think I need to find some better. This is my box. Beautiful box, because I have a beautiful things in this box, because I am loving my field. I think this is the best for this. Okay, so first I need to press this. Okay, just hold and don't do your feedback in this style. When I complete the work, after that you need to give your feedback for this action. So now I need to solder this. Because I have not a hydraulic press. Okay, I have just a soldering methods, and now I need to first hold. Oh man, first I need to tight this. Okay, and after that I need to just hold. Okay, and after that I need to solder this properly. Okay, now my soldering contact, I need to do some work for this. Yes. Yes. This is okay. And this is good. And now I need to install a shrink tube. A black shrink tube. But you need to install this quick, okay, like this. And after that, provide hot air, okay, to shrink. Yes. Now this is the best, okay. And here I am just checking the health of this. This health is good, okay. So I need to just press this, clean this little bit, and need to install a red color shrink tube, okay. This is already okay, but we just need to install a red shrink tube, okay. A piece, this is enough for this. It's okay. Muhammad Mahmood Chase. What is this? Oh man, I does the mistake. Now I need to protect. In this time, I don't need to read comments, but I need to now fix this. I was does a little bit mistake in this area. So now I need to install a little bit piece more here. Yes, now Muhammad Mahmood, what you want to say? Yeah, it's okay. That's it. Just little bit. I need to clean. What the name of this tool in English? Anyone can tell me what the name of this tool? I don't know the name of this tool. So if anyone know about the name of this tool, please tell me what the name of this tool in English language. Okay, this inverter is now ready for use. and I need to do some more works, and I need to write my money on this to charge, and I am telling you and writing you in USD. But okay, don't need to attach more tape. Here we have an area, so I need to charge approximately. In first I need to write in my currency 200 and okay, and USD 7.3 USD. Okay, for this work I need to charge, and I need to write here. Okay, so this topic is now closed. And now I tell you, this is our tomorrow project, so I need to complete my promise. This is our tomorrow project. Okay, this is the Growatt SPF 5000 TL HVM 48, and here we have a fault 03. Battery voltages is too high, and 08 bus voltages is too high. Okay, but this is our tomorrow project because this is the long time project, and for this project we need to have approximately 5 to 6 hours continuously. Okay, and now the time is here approximately over. Okay, because now here the evening. Okay, so the night is coming soon, so I need to do something related with previous product. Okay, so this is the first one was 1003 and this is the 1004. Okay, and this inverter is completely silent, and look at, man, this is the people who enjoying the electricity. No any feedback we are receiving from this inverter. So first I need to provide a power supply for this. Okay, I provide, but no any feedback, and this inverter is consuming 100 milliamps and 12 volts. Okay, so we have internal issue, so I'm just reassembling this. Okay, we have again empty. Oh, a man who install a plate screws. Oh man, as you can no, you cannot see. Okay, I am seeing with the eyes, but here we have a Phillips screws. Phillips mean 4 corners like this. Okay, and here we have a plate screws, so I'm trying on this, but this is not good for this. And I am trying this. man who install a plate screws. The people, what the people in this field who doing this type of works. Is this the thing, man? Now I have a big plate. This is not good. I have a this per plate, but man, salute to this man who install here a flat screw. Okay, I have some, and yes, but yes, this is good for this, but this is not good work to install a plate screw in this area, because this is the very deep area. This is the machine screw, and then install this. Salute to this person. And here we have another. The machine screw they install on the plastic body through it. Okay. Now I am teaching you. Okay. Here we have a glue, and for some persons very hard. Okay. To remove this, I am teaching you how you can remove easily if you have a hot air gun. Okay, if you have a hot air gun, so just provide a 180 or 200 degrees centigrade hot air. Okay, and let's check the magic, and provide a hot air approximately 10 to 15 seconds, and after that you can remove like this. Why? The glue is melted, or the glue was melted, and now the turn of this. Okay, first you need to apply a hot air on 200 degrees centigrade for 10 seconds, and after that you can remove easily. Okay, and now I need to remove this air ventilation core. Okay, and after that I need to clean this inverter. Please down your phone volume. Okay, down your phone volume. 1 2 3. Welcome back. I cleaned the inverter and now I need to remove and give me some time because I need to get my tablets. Just 15 seconds. Okay, thank you for time. And now I need to remove this one strip. Okay, the previous process, and now I need to remove this input and this is the output. Okay, and here we have a pen strip. Okay, and now here we have this plastics hooks for tightening the wire, and after that I need to remove this main screw. And now we need to work on some basics rules to repair this. A person try on this, but okay, sorry, I touched my head with the camera. A person who try on this, but he can't. Okay, push this hook and easily remove the main board from the body. Okay, first of all we need to check here the power supply section, but the main power supply section is damaged. As you can see, this is the main power supply area to provide power at different voltages for a different purposes. Okay, so this is our main power supply. Okay, and after that first we need to check our MCU microcontroller unit. Okay, so how you can check the inverter or any electronics MCU? Okay, first you need about the pin configuration, negative and positive, and after that this is our positive and this is our negative for this MCU. So keep your multimeter on the positive, keep your multimeter negative probe on the positive, and keep the multimeter positive probe on the negative. So here we have a true resistance. Okay, so it's mean our microcontroller is okay. And after that we need to check this without pen, because in some cases pen was jammed in the inverter, because the inverter providing a limited current, voltage is not okay, current, unlimited voltages and limited current for operating this system. Okay, and when the consumption is above from the limited current, in this case our inverter is not functional. Okay, so now I am just trying use your switch like this, and now I am turning on. The inverter is still consuming 100 milliamps. Okay, and now we need to troubleshoot this with the help of PWM rules and basics. Okay, first of all I need to tell about this inverter. Okay, our main negative battery voltages is coming here. Now I am showing you. Okay, first I need to set all the things in the camera, and this is our left, this is our right side. Okay, left, right, and same direction in camera you can see. Okay, this negative is coming here, the UC3845 PWM modulator. Okay, and I need to draw this PWM modulator basics. Okay, and if you know about the basics, so you can troubleshoot this issue. Okay, because this is not the flukes. Okay, this is not, you cannot fix this issue with flukes. Okay, it's possible, but if you have a supernatural help. Okay, sometime I was received, but no for every inverter. Okay, once when I can't with the help of theory and practical works, in this time I was need a help from the universe creator. Okay, because he know all about this. And why I am saying this, because he already created a billions of trillions of voltages in the sky. So this is not hard for the creator. Okay, here the same directions. Okay, the same direction, the IC is installed on the same direction. This is the up. Okay, this is the up. If I rotate on the sky like this is the upside. Okay, I'm just rotating. Okay, all the directions is just on the one side. Okay, and this is the good direction. The rules of the UC3845 is the world popular PWM modulator. This 4 number. Okay, note this. I need to remove a gloves. Okay, because I need to draw better circuit diagram. This is the basic rules. First I need to remove this to core this, and I need to get a clean white badge. Okay, I need some more. Okay, this paper is enough for this operation. First I need to a surface area like this. Okay, first I need to set my mobile direction. Okay, and hey YouTube AI system, please provide this audio and video who's searching about the UC3842, the UC3843, the UC3844, and the UC3845, because this is the very special rule to operate UC 3842, UC 3843, UC 3845, and UC 3844. First of all, this is the numbers UC 3 and 4 2. Okay, I need to set this and focus. Need to zoom in a little bit. Oh man, that's okay. Yes, this is the one. In the second, okay, I set the surface UC3 at 4 3 and UC3 at 4 4 and UC3 at 4 5. Okay, here we have this. Okay, but the pin configuration and basics, just the difference between the duty cycles. Okay, the UC 34 38 44 and the UC 38 45, this IC can provide you a 50% okay duty, sorry, I write a capital duty cycles. Okay, this can provide you a 50% duty cycles. Okay, and this you see 38 44 and 38 45 is providing you, can provide you a 50% duty cycle and 500 kilohertz frequency. Okay, and these two ICs can provide you a 99.9% duty cycles. Okay, this and this. Okay, the difference is just about the duty cycles. Okay, now here I am driving IC. Okay, some countries are marking this type of cut for pin configuration, and some countries writing or engraving a dot on this left side for the pin configuration. Okay, my driving is not good, but okay, I need to rotate my mobile and this paper for best direction to me. Okay, I'm just rotating my mobile for best driving. How can I rotate? First I need about this rotation, man. Okay, I learn. That's okay, and now I need to set this for better. That's okay. Yes, okay, now this is the best direction for me and you. Okay, and I draw a little bit to right side. But how you can find a pin number 1 if this off? Okay, this side you need to set on the sky direction. Okay, up side. Okay, so here, from here you can find pin 1. Okay, and here 2, and here 3, and here 4, and you can turn like U. Okay, when you driving a U, ultraviolet U. Okay, so you can this 5. Okay, here 6, here 7, here 8. Okay, in the basics rules, this pin for feedback, what, sorry, for capital F, feedback. Okay, and this is for compensation. What? Compensation. Okay, this is for compensation. And the pin number 3 for I sense. I sense mean ampere sense. You can limit the output PWM duty cycles with this pin. I sense, ampere sense. Okay, I sense or ampere sense. And the pin number 4 for RT. Okay, RT mean resistor timing or resistance timing, and CT from RT resistance timing. Okay, resistors timing, resistance timing, and CT capacitor timing. Okay, capacitor timing. Okay, this pin is explained, this pin is explained, and this pin now I need to explain. And some topologies here, if you need to just get a PWM from this pin, this is the PWM output pin. Okay, PW pulse wide modulation out. Okay, and the symbol or icon is like this. Okay, this is for pin number 6, and this is the negative. In some countries called the G and D. Okay, are negative. I need to write this on black color because this is the DC. Okay, negative, black color. And here we have a pin number 7, VCCR plus positive. Okay, this IC can observe up to 30 volts DC. Okay, but for best performance you need to provide 12.5 to 14 volts. Okay, for best operation. Okay, now this is our pin number positive 7, pin number 5 negative, and this is the pin we can call V ref Vref. In data sheet, it's mean voltage reference. And if you are trying to make a buck boost converter or step up and step down converter, so you can adjust your frequency. From here I am just driving for you. Okay, from this pin you need to attach a potentiometer. The potentiometer icon is that. Okay, this is the potentiometer symbol. Okay, and you need to connect this. I am removing this thing. Okay, you need to connect with this pin number 4. Okay, so I am here connecting. Okay, and you need to connect this. I am connecting here. Okay, for saving the area you need to connect this. Sorry, I touch my head with the camera here. Okay, this is par. You can adjust the frequency of this modulator with the help of 10 kilo ohm potentiometer. 10 k ohms potentiometer. Okay, and you can call this variable resistor. Okay, and here is your, now we need to a CT, capacitor timing. So this is the very big calculation, and I am also using this app. First I need to search about, okay, install this app. This is the best if you need, if you want. This is the UC. As you can see, the UC. First you need to know about, this is the F. Okay, learn about, this is the power calculator. Okay, install from Google Play Store or iOS, but this is the best. Okay, and free. If you need to know about, I am using this after long time, so okay, give me some time for thinking. Okay, first you need, I was told you, and first you see 3845 and you see 3844. Okay, and here as you can see, you see 3845 and you see 3844 in separate area, and you see 3842 and you see 3843 from here. Okay, and another area. Why? Because the difference is just duty cycles. Okay, so if you know about a frequency focus, okay, here I am installing, for example, this is the popular, and you can find this in every electronic circuit, the non-polarized capacitors. Okay, this is the icon of this capacitor. First you need to know about this capacitor. This is the non-polarized capacitor symbol. Okay, non-polarized capacitor, for example 10 NF. Okay, and if I provide a 4.7 kilo ohm resistor directly without potentiometer, okay, so now we marked to focus on frequency. Okay, so if we connect here 4.7 kilo ohm resistor with the pin number 4 from pin 8 voltage reference to pin number 4 RTCT, and here we install a 10 nanofarad. Okay, it's mean 10,000 picofarad. Okay, I am just removing, as you can see, NF. Okay, it's mean nanofarad. Here I am adding F. I have here a 10 NF capacitor and 4.7 kilo ohm. Here are, as you can see, kilo ohm. Okay, k ohms 4.7. Okay, now if you calculate, okay, you can receive a output frequency from this two modulator UC 3842 and UC 3843, 36.6 kilohertz oscillation frequency. Okay, but if you are using a 50% duty cycles, okay, so if I select this and calculate again, so here you can receive oscillation frequency 18.3 kilohertz frequency. Okay, and I am here, I need to draw for you here. Okay, I am connecting with this pin. Okay, with this pin here, a non-polarized capacitor, the value is 10 NF. Okay, and this 10 NF can provide you from here, if you are adjusting, approximately as 86 kilohertz frequency you can receive from this 10 NF. Okay, and now I am connecting with this pin. Okay, so this is your circuit completed. 10 NF non-polarized. Okay, capacitor, non-polarized capacitor you need to install here. Okay, and you need to provide for step up or step down converter to this negative. This is the compensation pin. You need to provide directly a negative voltages. Okay, so this is our pin number 5, and you need to solder a wire with star configuration. Okay, this you can call star configuration. You need to get all negative from here. Okay, so we need to connect this. I am connecting with the pin number 5. Okay, and now I need to make a jumper. This is a jumper. Okay, jumper to connect with this pin number 2. Okay, and if you want to limit your current for output load, so you can hear if this is our main negative power voltages power source. Okay, so you need to first provide, this is the star configuration. Okay, this is our main negative and this is our main positive DC voltages. Okay, and it's not depending on voltage. You can provide here 100 and 200 and 300 and 400 voltages. Okay, but here you need to provide a 12.5 or 14 volt power supply to operate this PWM modulator. Okay, so now you need, for current limitation, to install, first you need to install with this star configuration. Okay, I am just connecting here. First I need to provide a negative power supply, okay, with this negative, okay. First of all, you need to connect with this star configuration, okay. And after that, if you need to limit, you want to limit your current, so here you need to install a shunt resistor or wire wound resistors. I am showing you what is the wire wound resistors. This is a carbon film resistors, okay. No any, this is the surface, okay. If you are looking this on the side, so no any wire you can find, and this is the carbon film resistor, and this is the wire wound resistor. As you can see in the internal side, we have a wire, okay. I need to remove this coating just for you, and I need to show you a wire, because here I am sharing a knowledge, okay, and I am just doing this job with my own hobby, okay. This is my hobby from last 21 years, okay. Don't worry about my fingers, okay. This is very hard fingers. I am here not doing any arrogance, but this is just the confidence, okay. And I need to show you what the difference and why I'm using a wire wound. This is the wire wound resistor. As you can see, the wire here are come to here, okay. This is the wire wound resistor, and this is the best to use in this circuits, okay. If you are using a lot of current, so you need to install a shunt resistor. And now you think about what is the shunt resistor. Multiple types of a shunt resistors, okay. I am finding here, if I found, so I need to show you, okay. Here I have no, okay. Here I have this is the shunt resistor, okay. This is in the real time, this is the resistor. I hope you, some viewers are looking this at first time and hearing first time, okay. Like this are sense ones, okay. This is the shunt resistor just for sense, okay. And they can provide us 100+ amps, okay. And this is the voltage drop in this pin. How can measure this MCU? This is the microcontroller. This is the role and the basics of voltage drop calculation, okay, from this side and from this side, okay. When we apply a current approximately 100 amps, so here we can receive just 15 to 25 millivolts, okay. In this, the microcontroller can read this drop voltages to show you amps and LCD and much more things, okay. Now I need to here install shunt resistor or if you are using just for 2 or 3 to 7 amps on the input, so you can install just a 0.22 ohm, mean 220 milliohms, and parallel approximately 4 to 5 resistor you need to solder with parallel. Okay, and install here. Okay, this is the shunt resistor or I sense resistor. So I am here writing I sense. Okay, first you need to connect this shunt resistor or wire wound resistor to direct here. And if you are using a MOSFET for switching like that, if you are using a MOSFET, sorry, I draw the MOSFET body with the black color. Okay, but this is pin 1, 2, 3. Okay, 1, 2, 3. Get drain source. This is the N channel MOSFET, for example. N channel. Okay, you can zoom with your own. Okay, I was provide a very high quality internet to provide you a 1080p video for this operation, so you can zoom in. Okay, to focus on these things. Okay, for example, if you provide this source, okay, this source, so you need, this is the wire power source, you need to connect this with shunt resistor, and you need to connect this with, okay, this is the I sense. First you need to provide from here this star configuration. Okay, not from, if you provide, if you thinking about here is our negative, why I am not providing from here to this with the resistor? No, the rules is the star configuration. Okay, so you need to install here a resistor from this star configuration. Okay, so you need to get a wire. Okay, I am here, I am for jumper. Okay, this is the jumper, this is the jumper. Okay, and you need to install here a resistor 3 point, you can install 3.6 kilo ohm. Okay, and 0.25 watts. Okay, or 0.12 watts. Okay, mean a quarter of watts, it's mean 0.25. Okay, so here you need to install a resistor. This is the resistor symbol. Okay, and after that you need to install with pin number 3. Okay, and after that you need to install for current limitation. For current limitation, if you want, you need to adjustable and variable current limitation. So here you need to connect from here this MOSFET, this area, okay, potentiometer, okay, 10K ohm. This is the popular potentiometer you can find in any electronics thing, okay, easily. So you need to connect this. I am connecting this with this black, or I need to draw some more colors or easy, okay. Now I need to connect this. I am for jumper, okay, and you need to connect with pin number 3, okay. So you can set from here your current limit, okay. And now this circuit is depending on your product, okay, or your project, like step up, DC to DC step up and DC to DC step down converters, okay. And this PWM you need to connect with this MOSFET gate, okay. And the drain you need, and we need to discuss this with another video. For step up and step down, I was done this approximately 2.5 years ago, okay. And now I was through these circuits in scrap, because now I need to troubleshoot the heart-to-heart issue in inverter, okay. This was my first DC to DC boost and DC to DC buck or step down converter. Here you can see I install for iSense, okay. And this was the isolation DC to DC step down, because here I was install a transformer, and now no anything I have here, because this is I was done 2.5 years ago, okay. And I use some multiple times this for step up and step down, and I wind this, okay, as you can see here. A lots of some things we will discuss later, and make a good quality step up and step down converters, okay. But later, not now, okay, when I get a time for this. First I need to clean this, complete clean, okay. And I need to place one component, and I need to share with you like this main basics, okay. So I hope, okay, this 2 pins is now remaining. So for PWM output you need to connect this pin number 2 compensation pin with negative directly with the help of star configuration, okay. And this is the VCC, and now I need to troubleshoot this silent or dead inverter with the help of this theory, okay. This pin is related with your output constant voltages, okay. Now I need to draw one component to understand complete circuit, okay. This is the PC817 component Okay, this two pin is connecting with this like this. This is the pin number 1 for operating the internal LED, and this is the pin number 2. This is the positive, this negative, and you need to provide. This is the PC817. I am here driving. Okay, you need to install. Okay, this one and this one, and I am driving here this component. Okay, PC817. This is our PC817. This is our pin number 1 LED. Okay, LED side, and this is the resistor side. Okay, the internal block diagram is like that, I think. Resistance. Okay, and this is dependent on this LED light. So I am imaginating for the LED symbol. I think the LED symbol is that here is a diode. Sorry. Okay, here is a diode, and this LED diode light, when you providing a voltages, this resistor is depending in the block diagram on this LED light. Okay, here are install LDR. What? LDR, like LDR, light dependent resistor. Okay, and this is isolate. If you provide a feedback voltages to here, so this is not the voltages coming to this resistor, because this is dependent on light, and light cannot provide a voltages here. Okay, so this is, you need to connect this, the pin number 3, sorry, the pin number 4 with the pin number 1 of this modulator, and you need to connect the pin number 3 with the pin number 2 of this modulator. Okay, and here you need to install on this negative and positive one resistor of 1k ohm. Okay, and now this LED voltage is depending on your feedback circuit. Like if you need to 12 volts, after that we need to discuss that. If now I am more explaining this thing, so in the whole night I cannot explain this, man. And the topic is going to very beautiful discussion. Okay, but from here I complete your pin configuration. Okay, now this LED site is dependent our feedback circuit, how many voltage our requirement. So we can fix this with the TL431 and one 10 kilo ohm potentiometer and some 2-3 resistor. We can fix our output voltages. Okay, constant output voltages with this component. Okay, and you can provide without this with NPN transistor to feedback from this pin to this pin. And the logic is here, when these two pins are connected with each other, or you provide here for example a 12.5 volt from here, and when you provide to this pin 12.5, so the IC is going to stop the PWM output. Okay, the whole game is here. Okay, and after that I need to complete the step up and step down, and I need to guide you this magic. So after that, when you know about this feedback circuit and this iSense and this PWM, you can create every step down and step up converter, DC to DC step down and DC to DC step up converter, like from 500 DC volt to step down 5 volt DC you can. Okay, and this is my challenge. I can provide you from 500 volt DC to provide you a 5 volt constant DC and 100 amps and 100 amps. Okay, and you can boost with this formula from 12 volts to 500 or 900 voltages. Okay, if you know about the complete circuit, and one day, if God will, I will share the man everything. Okay, not with one specific circuit, like just draw the circuit diagram and make quickly a DC to DC step up or DC to DC step down converter and get views. No, I need to teach the formula. What is the magic here? You can make every step down and step up and step down converter with your own, and 100 amps, 200 amps, 300 amps. It's dependent on your MOSFETs and IGBTs and inductors. Okay, not on the formula. The formula can provide you and 1,000 amps. Okay, in 1,000 amps, but 1,000 amps is dependent on your MOSFETs, your soldering, your induction. Okay, your inductor. So I have big inductors. Okay, I can use this inductors approximately 100 plus amps, as you can see the wires. Okay, so I need to clean this for my next project to make 100 amp step down converter with adjustable output voltages, constant voltages, and adjustable current limiting. Okay, now we need to just check our this circuit. Okay, now I am just providing a power supply, but I was provided already. Here I have a damaged or devalue resistor, and a person who installed a wrong number in this area. They install here IRF630N. Okay, they install a true number, or this is from, no, this was installed from the company. As you can see the soldering. Okay, you can guess with the soldering. So first we need to check our N channel MOSFET, but I know the color is changed, so I need to just remove this MOSFET, and I need to check this PWM modulator in the circuit, and I can check, okay, with the theory, with the help of theory. So first I need to remove this MOSFET from here. Okay, first I need to remove this MOSFET. I have a call. Hello. Walaikum salam. Here then. सुनो मुँह पे فالट خي څه نمبر فالट خي نو نو بس بیا یې راوړه چې جوړو یا بیا په دې اسمان برېښنا کې به خراب شوی لایټنینګ okay sorry for wait. Okay, first I need to remove this MOSFET from here. Okay, now I need to remove the solder from this solder masks. And I don't receive any comment. Who are watching my videos now, my live stream now, and are you understand what I was share you, or you not understand? Who understand? And here I need to get you my email address. If you have an issue, you can text me on email, and here I am writing my WhatsApp. Okay, you can ask me any question. If I have an answer, okay, so I can give you an answer. If I will have. Okay, so now here I am adding my email address. This is my email address. Okay, and here I need to give you my WhatsApp. If you cannot do or send email, so you can ask me directly on WhatsApp. And this time I have no WhatsApp on this number, but after this live I need to sign in to my this number. Okay, because this is my personal number and I cannot here type a business number. Okay, so this is my personal WhatsApp number, not for business. So you can ask me about the electronics any question, and if I will have your question answer, I can give you. Okay, if God will. Okay, this is my WhatsApp. I was add a number. Okay, no anyone adding or number, but I can. Okay, okay, now I need to remove this 20 ohm resistor. If a person who have a damage value here and he don't know about this value, the value is 20 ohm and the size is 1206 SMD, surface mounting devices. Okay, here I am removing with the soldering iron. Okay, I am not using a hot air gun because here are the capacitors and the hot air is not good for the capacitor. Oh man, Okay, and now I need to clean this again. Sorry, I touch again my head with camera, and nearly I am purchasing a good quality camera to zoom in with remote control, and it's hard to zoom in with smartphone. Now I am using a smartphone for live stream. Okay, and we miss a one solder mask because the resistor was burned very badly, and the PCB is burned is okay because the resistor was burned, so we have no any print for the gate, but we can provide. Okay, here I need to make a special thing for this. So what I need to do? Okay, first I need to check the UC3845 and this circuit. Just okay, this is the same direction of the pin configuration. First I need to set my multimeter on continuity mode, and first you need to keep your multimeter positive probe on the pin number 5. Okay, pin number 5. Okay, and you need to keep your multimeter negative probe on the pin number 7. Okay, here we have a true continuity. After that we need to keep our multimeter negative probe on the pin number 6. Okay, 637, and here we need to have 100 ohm more than from previous reading. Okay, so I am here keeping the multimeter negative probe on the pin number 7 and the positive on the pin number 6. Okay, it's mean with the theory our UC3845 is okay, but first we need to confirm this with voltages, and after the voltages we need to confirm the VWM modulation with the oscilloscope. Okay, now I need to check, but first I need to share my multimeter value with you. So what the better view? Okay, this is the better view because you are just viewing, and I need to, but this area is not. Okay, if I keep this on this method and this on this method, and I need to measure perfectly and keep multimeter probe safely. Okay, if you touch the pin number 5 and pin number 6, it does not matter because you provide, but we have no MOSFET here, but we can damage our PWM modulator. If we touch the pin number 5 with the pin number 6, it does not matter, but if we touch the pin number 7 and the pin number 6, so we can damage our PWM modulator because the pin number 7 is VCC. Okay, so now I'm just providing the power supply to the inverter. It's okay, I provide. Don't touch, man, don't touch. Okay, now I need to install my switch, okay, for easy operation. And now I need to set my multimeter on voltages, DC voltages. If you have a manual multimeter, so you need to keep your multimeter on 20 volts. Okay, if you have a 12 volt, uh, okay, you can just for 20 volt, because the voltage is fixed for this PWM modulator. Okay, now I need to connect easily with this, but first I need to confirm, so I am removing the power supply again, okay, to teach you step by step. And now I am just setting my multimeter on continuity mode, and after that I need to check the negative, okay, with pin number 5. Okay, as you can see and as you can hearing the beep sound. Okay, this is the true value. Our negative is coming to our PWM modulator pin number 5, and now we need to confirm for the source. Okay, the n channel source, this is the gate pin and this is the source, but we have no any continuity to provide a negative power supply for this source, because our MOSFET is damaged and our this I sense resistor is too damaged. Okay, like this we have here a I sense resistor. So with this formula I need to check and share with you. Now note the formula. This is our negative and this is coming with the I sense resistor to this n channel MOSFET source. So I need this continuity like this. So this is our negative. Okay, this is connected with the PWM. I was told you the star configuration. So this negative is directly coming to this PWM modulator, and this is our MOSFET source pin, but we have no any continuity. So the meaning of this, the reason of that, I need to remove this and I need to read the value of this resistor, and I need to first replace this resistor, because first we need our basics to provide this inverter circuit. Okay, now I'm just removing the resistor. So okay, and this is the very unique technology, and this is the very interesting thing for me. Okay. Mm. Okay, this is our high sense resistor. Okay, now I am checking here an open area, no any continuity we have. Okay, and now I need to check the resistor value. Live plus, how would you know what value a resistor was? If you want to replace one that's blown, please help. Live plus, how would you know what value a resistor was if you want to replace one that's first we need to install a designer value. Okay, and if you shunt this, you can shunt, but if any short circuit come again, so we can damage or this area. This resistor is installed for current limitation, and I was discussed all about this PWM circuit. You can watch Okay, and now I I remember a lot of things, but one thing I can't remember, this color coding. Okay, this is my weakness. So now I'm just removing my tab to read this with you. Oh man, come. I'm removing my tab from my stand. Oh man, I need to remove carefully. Yes, okay. And now this is my live stream, and this is the resistor color code. Okay, so here we have a resistor color code, and this is the 3 band. I need to here add 4 band resistor. So this is our brown first, brown second, green third, silver, and the last we have a gold, the tolerance. Okay, this is related with the percentage of the tolerance, like 100 ohms. If we have here a gold value, so we can receive from the manufacturer 105 ohm, and we can receive from the manufacturer 95 ohm. This is the meaning of this color. This is the 5% up and down you can receive from the manufacturer. Okay, and come the resistors, and 2% and 1% and 0.5%. Okay, so our value is 150 milliohms. Okay, 150 milliohms. Okay, I am sharing you what the value of this resistor. This is also in milliohm. Okay, apart a 1 ohm you divide in 1,000 pieces, and after that the resistor value is 150 milliohm. Okay, in 1 ohm is equal to thousand sorry bar bad writing, 1,000 milliohm. Okay, 1 ohm is equal to 1,000 milliohm, like 1 kilogram is equal to 1,000 grams. Okay, 1,000 grams, like this. We have a 1 ohm is equal to 1,000 milliohm, and the final thing is we have a value of this resistor 150 milliohm. Okay, now we need to install a 150 milliohm resistor, and if you don't have a 150 milliohm resistor, so what you need to do for this value? Okay, so in this case you can use the ohm law. Okay, with the help of ohm law you can make your own resistor like this. So here I have a 220 milliohm. Okay, and another side I have a 470 milliohm resistor. So first I need to collect from my brother, because I was just here a one resistor, and okay, the value is 220 milliohm, and this is the carbon film resistor, and I don't want to use this. Okay, I'm just collecting from the basement from my elder brother. Okay, I received some resistor from my brother, my elder brother. Okay, here we have a 470 milliohms. What? 470. Sorry, this is the M and milliohms. Another side, I have a 220 milliohms. So we need the ohm law, and if I install in parallel 220 ohm, it's mean this is the 110 milliohm. Okay, and here we have 150 milliohm, so we need to just more effort. For this I'm searching for ohm law, and the ohm law I think I have in this every circuit simulator. And the one beautiful thing is that, man, if you are interested in electronics, purchase this app, and this is the best simulator I am using always. Like this laser security divided by 4 BMS and flute charging circuit. If I select one, this is the operational amplifier. You can change any value, and you can in the real time result. Okay, the F name is every circuit. Okay, and this is the pad. This is my name, Shahid Anwar. Okay, this is the icon, every circuit. Okay, but this is the paid app, not free. Okay, now I need to the ohm law. Okay, I need to remove my tab again from here. Okay, and this is the electrodroid famous resistor ratio, resistor series and parallel. Okay, F If I select this, okay, this is good result. The one side I have kilo ohm, so we need milli ohm, okay, because we have our resistors in milli ohms, not in ohm, not in kilo ohm, okay. One I have a 470 milli ohm, okay. Set that 470 milli ohm, and other side I have a 200. Here first I need to set in milli ohm, 220 milli ohm. Here, as you can see, wow, man, 149.9 milliohms. Yes, this is the best luck of me. Whew. Okay. So we need to make a parallel circuit from 220 ohms and 470 milliohm. Okay. So I need to wound this. Okay. Wound this. That's okay. And now I need to wound this. Sorry for my long nails, no long dirty hands, okay. But one thing I need to say, the dirty hands is the sign of clean money. What I said, the dirty hands is the sign of clean money, okay. And now I can install this, okay, because I was show you and the Om La. Okay, now I need first to solder this. That's okay. Okay, and first I need to check the area for this too. First I need to confirm this. If I install on this direction, I have an area, okay, and if I install in this, I have not an area, okay. But if I install this, no, I need to install like this, okay. First I need to clean this solder masks. Okay, I clean this, and now I need to solder this and install this. Okay, I solder this. Lio Plus, I solved your issue, man. Where are you? Are you watching my video? Are you leave? You was leave the live? Hmm? No, any comment? Where is the live chat? Oh man. Okay, where is my live? Here. Okay. Thank you for all viewers. I waste your time. You are just excited for this, and I was drop much more circuits. But this is my goal to teach you, okay? Not just understand you with the something. This is for your whole life, okay? You need to learn. And just remember me in your phrase, your prayer, okay? Just remember me in your prayer. God solve my some issues I have, like circumstance I can call. And I have a child, prepare my child, okay, because I'm teaching you with the very basics rules, and I was not found in the YouTube like this teaching, and I learned this very hardly, okay. No any teacher I was have here to teach me. Oh teacher, how can I fix this problem? Please teach me. No, I learn all from the data sheets. Okay? And all from some YouTube tips, but not like this. Okay? Now we need to check our continuity, our resistor. Our resistor is fixed and no any issue. Okay? Now I need to check the continuity from battery negative to N channel MOSFET source. Okay, this is our MOSFET source. Now as you can hearing and as you can see the multimeter, now I am receiving the continuity. Okay, but why the 0 ohm resistance? Because this meter cannot read the milli ohm resistance. Okay, this meter cannot, if I using in milli ohm. So now I need to try. First we need to check our probe resistance, so they can read. We have a 300 milli ohms resistance and our probe. Okay, and after that, remember, we have a 300 milli ohms resistance and our probes, and after that I need to keep on this what the result. This is still showing 0.3. It means they cannot read the 150 milliohm more resistance. So okay, we are connected with the resistor. Now I need to provide a power to the inverter. Okay, and now the time to receive a PWM with the multimeter and with the oscilloscope and everything. Okay, I'm just providing a power, and after that you need to connect the multimeter negative. First I need to show you the multimeter. It's okay, connect the multimeter negative with this main negative, with this main negative per AC reading. Okay, per AC reading, because here I have no any other person, so I connect with the negative. Now I need to install a switch again. Okay, this is a switch I install. First you need to off the switch. Okay, this is my switch position. I know about the switch is off. And now first you need to keep the multimeter positive probe on the pin number 7 of UC3845. Okay, here install a UC3845. Okay, so I keep the multimeter positive probe perfectly on the pin number 7 VCC, and when I turn on, as you can see, okay, the voltages is coming and now downing. Okay, this is the true thing. We are receiving our first operating voltages. Okay, this is the good thing. Listen, sorry, Look at, okay. When you on the inverter, okay, we receive a voltages. I am setting a multimeter on the maximum range, and this is the other special thing. And now check, okay, but we have with the range of 6 volt. First I need to up my multimeter again, and now I need to set the manual range. Okay, this is the 60 volt, and now I need to keep the multimeter positive probe, and once I need to the maximum. Okay, yes man, now I need to touch on. Okay, I can receive the maximum at 0.18 volt, and this is the good thing to operate the UC3845 first pulse. And after that, now the turn to receive a PWM output. So this is our pin number 6 PWM output. Okay, now I need to receive a PWM output. As you can see here, the range. Okay, yes man. Okay, now I need to show you with the oscilloscope. Okay, but here I am alone. First give me some time to I remove your my cell phone. I need to read on this sweet comment. I will remember you and my friend. Yeah man. No man, mean just prepare me, just prepare me. I have some issue. You don't understand man, and I cannot speak strong English, and I am a human, I can mistake. Okay, and every live stream I am saying I can mistake, I am a human. Okay, my mean is that just prepare me. Okay, just prepare me. I have some issues not related with works. Okay, other issues. Always be positive. Okay, always be positive. Here I am discussing no any religion. Okay, no anything. I am just discussing about the electronics, but I have some issue. Okay, not in this. Okay, I have some issue, and I need to solve this issue, but with the help of our creator, your creator, my creator, this universe creator. Okay, so I just told you about this, and now I need to show you the oscillation of this PWM modulator. Okay, man, I am not an English speaker, so I need to don't speak anything without this circuit. Okay, because I can do the mistakes and other talks. So sorry for that, and next time I need to don't discuss other talks in live stream. Okay, but why I said yesterday, and I was face much more difficulties in my life, especially in the night. Okay, some things are disturbing me at the night, and I want to make cry, but no anyone can providing me the help without the universe creator. Okay, For this thing, I told you, remember, if you are praying from the God, your God, my God, the universe creator, so please remember me, God. Please help this person. Help this person. Okay? This is just my request to you. And I don't know how you feel, man. This is okay. Now I am just connecting the oscilloscope probes, and next time I need to don't talk about with without these circuits. Okay, I need to take care in talks. Okay, now you need to connect the oscilloscope negative probe with main negative, with this negative. Okay, with this negative. Okay, and I am just connecting my multimeter positive probe like a wire with the oscilloscope crocodile positive clamp. Okay, to keep on the pin number 6 to read the oscillation frequency with the help of oscilloscope, my mini oscilloscope, and don't log on my oscilloscope. Okay, I was purchased this and 21.6 21.6. Okay, 2016 I was purchased. Okay, now I am removing my cell phone. Yes, God help me. Okay, okay, I was removed. Okay, wait, I have a friend. Come, bus last. Rashda लट कर इसे Rasha. Word brothers. Rashda लट का. रूर में नहीं. Please ये लगा लास्ट की मोबाइल ले मात पशीदा Google. Word dear. दाउनी सारा देखे. Okay, close में चला है. आपने ने उस स्कूप दामा तलक बोली सा. Okay dear, I get a one friend. This one is a kanza kuma. This one is a naughty friend I received. Okay, now I am just keeping here on the pin number 6. Pin number 6. Okay, for oscillation frequency oscilloscope don't source. And now I am just turning on, and you need to focus on oscilloscope. Okay, vertically. Okay, as you can see the PWM modulation we are receiving. Okay, it's mean our PWM modulator is in the working mode. Okay, now we need to just install a 20 ohm resistor and one N channel MOSFET. The MOSFET number is IRF630N. Okay, now I am just keeping my cell phone again in my stand. كين بس بمر بدي بس ترى أنكي تبرع نيجي كين سيد كين راح زمان لغاس كل لغا بس تاخد بدو والده بس ته سيب إن channel MOSFET operate كم بس تبرع electronic innovation. Are you shared your knowledge with people before my live stream? Man, this is not just the talks. Okay, I am checking your channel now, how the knowledge and what the knowledge you share with people. Now I am just checking your channel. But I don't care. Okay, now I need to just install one N channel MOSFET and 120 ohm resistor. Okay, to troubleshoot this issue, and I will see you tomorrow with next project. Give me just 10 minutes. Okay, brother? Okay, brother? Not for viewers. I told just to my friend. This is my friend and this is very sweet boy and also helping me in my works and my cameras and my apps, purchasing apps and sitting the live streams and much more. And finally I get at the time. And this is our music and joyful moment, but I need to install and just end the live stream. Okay, I'm just searching for IRF630N to install. Bikin master na bomba. IRF 630 David tahu Korea 640 ay sana. Okay, first I need to disconnect the power and discharge the capacitors. Okay, and after that I need to install this MOSFET in this area. So I need to bend this with this direction. Okay, no man, okay, it's okay. This capacitor, okay. Now I need to put in the specific area. Okay, now I need to apply some force. That's okay. And now I'm just soldering this, and after that I need to install 120 ohm resistor, and after that I need to tie on this inverter. Your mistake, okay, now I'm just getting to 20 ohm. Subimos again to the okay, on this side we need to install. This is the top side of board. Masalah lewat tangga gutira. Osu cokolo ki waladu boma. Awas panean sida bilkul dente. Para gun mo na ochilo kasam. Okay, in this case I need to apply some hot air, but this is not good for capacitor, so I need to melt this solder and place this resistor with little bit efforts. That's okay. I connect the one side, and for another side we don't have a copper line, so I'm just connecting this with solders. Okay, because we have just a 2 mm or 1.5 mm distance, and you can core this with 200 degrees centigrades. Okay, set your soldering iron on 200. Oh man, first I need to fix this, and I need to wait approximately 10 seconds to cool down my soldering station. Now I can. Okay, yeah. Oh man, Okay, finally I attach the solder with another side. Now the time to turn on this inverter. Okay, I'm just providing the power supply to the inverter. Okay, and after that I need to install temporary a cooling fan just for feedback, and now I am turning on. And as you can see, and you can hearing the sound, and inverter is now okay, man. Just on first try. So, okay, this is my multimeter. I was set on AC voltages, and this is the output line and neutral. And as you can see, at 206 volts I am receiving. Okay, and this is not the constant power supply. The reason is that not stable voltages because my bench power supply is not constant. Okay, because I am working on SMPS. When I install some SMPS more with this bench power supply, so this is not good for me. But as you can see on the first try, I turn on the inverter. This is the logics, and this is the game, and this is the experience, you can call everything. And if God will, I need and I want to share you everything. And see you next time. Lio Plus, hi to Joaquin Moiler, hi brother. Now I saw your comment. And Lio Plus, brother, I was does one mistake, and I need to don't talk about more talks. Okay, without this board. And see you next time. Take care. Have a sweet dreams. Good night. Because here is the time is 7:02 p.m. And take care. See you next time if God will. Bye.